Dr. Toll's thesis on the seismic studies of small-scale models of adobe houses was conducted at Stanford in the 1980s. Model 1 simulated a typical Mexican earthen building with a 6-inch earthen roof. During test 6, the walls nearly overturned, as shown in this high-speed video sequence. The front wall would have collapsed if it were not for the corner connection that extended around to the left that provided additional stability to the wall. In test 7, where the accelerations topped 35% of gravity, the walls collapsed easily. The front wall collapsed in that sequence. The rear wall nearly collapsed at the beginning of the test, but did not collapse until the latter part of the testing sequence, as you see now, with the left wall in the rear collapsing. Model 3, which was originally intended to be the first model in the testing sequence, had heavy steel roof beams that were there to simulate both the earthen roof, 6-inch earthen roof, but also the roof beams and how they connect the out-of-plane walls. Typically, there is not good anchorage in this area, but in this model, the steel roof beams were solidly anchored to the front and the rear walls. As you can see, the out-of-plane behavior is quite stable in this testing sequence, and the walls were nowhere near collapsing. This behavior continued through test 7, which easily caused the collapse of the building, where there was no anchorage between the opposite long walls, which were subjected to the out-of-plane motion. The in-plane walls, as shown on the left with a single window opening, actually were the part of the building that failed during this test sequence. The out-of-plane walls did not come anywhere near collapsing during this test, which shows the effectiveness of coupling walls. The rear wall was a solid adobe wall. The front wall had a door and window, so their basic dynamic behaviors are different, and they acted to stabilize each other during this testing sequence.